Hi everyone. Now we are going to see about the characteristics of DC generator. So in a DC generator, so there are open circuit characteristics and load characteristics are there. So in a separately excited DC generator, so here the field and armature both are kept in separate condition. Here for the field winding we are giving the separate supply and the armature will be separate. So the ammeter which is used to measure the amount of current which is supplied to the field, and this is to measure the voltage and current which is supplied from the armature of the DC generator. Okay, so at initially the rheostat is in maximum position. The rheostat is in maximum position. So the resistance is high. So because of high resistance, the field current will be very low. The field current will be very low. Once the field current is very low, the amount of flux which is produced is also very low. The amount of flux which is produced is also very low. So once the flux is less, while rotating the armature, it cuts only lesser amount of fluxes. So it cuts only lesser amount of flux and it induces only low voltage Once, if you are trying to reduce the resistance with the help of this rheostats, once we are starting to initiate, while reducing the resistance, the field current, the current which is applied to the field, gets increases. Once the field current is increases, the flux is also increases. So we can able to increase the more fluxes. So in the fluxes increases, the armature it cuts the fluxes and it induces the voltage. So if the fluxes increases, the induced voltage is also increases. So this is the relationship between the field current. This is the relationship between the field current versus the generated voltage. The field current versus generated voltage, it is nothing but an open circuit characteristics. Okay, so this is nothing but a field current and this is nothing but an open circuit voltage. At initially, okay, the field current is less, the voltage is also less. Once if you are increasing, okay, once if you are decreasing the resistance, the field current gets increases, so the flux is also increases. Okay, so here now we may, so this is for 1500 rpm and this is for 1600 rpm, this is for 1600 rpm. For different rpm we are getting the different curve. So this simple logic is, okay, so the simple logic, the open circuit characteristics, the induced voltage is gradually increases with respect to the corresponding field current. And the next one is the load characteristics. Okay, so during the load characteristics, we have to maintain the field current as constant. So which current has to be maintained as constant means, so for example, which field current is producing the rated voltage, the amount of current which is used to maintain the constant or rated output voltage, that field current has to be maintained as constant. Okay, so at this time now we are changing the load, because this is nothing but an load characteristics. Now we are increasing the loads gradually. For example, at initially there is no load. Now we are adding 1 amps, 2 amps, 3 amps, 4 amps, like that. Just we are adding the loads. We are increasing the loads. Once the loads are increases, the load current, the current which is taken by the load is increases. So the voltage gets dropped. Okay, the voltage gets dropped. So this is mainly due to the load. The first curve So now the first curve, it is mainly due to the armature resistance, and this is mainly due to the load. This is mainly due to the load. So here the field current is maintained as constant to supply the rated voltage. So while increasing the load current is increases, simultaneously the voltage which is supplied to the load is also decreases. It gets decreases. So we have to plot the characteristics between the increased load current. Increased load current. If you are increasing the load current will be increases and the voltage should be decreases. So this is the curve between the load current and the voltage. And the next one is DC generator characteristics. This is nothing but an external characteristics, which is similar to the load characteristics. It is mainly to determine the voltage regulation. So this is the EM minus terminal voltage divided by terminal voltage into 100. Okay. So this is the assessment. The terminal voltage of a DC shunt generator drops on load because of all the following reason except. And the second one, which of the following generating machine will offer consistent voltage on all loads? So put your answer in the comment section, and these are the few references. Okay, thank you.